Hello everyone, welcome back to another Web3 Concepts video here. Today we're going to be looking at proof of work, or sometimes referred to just as PoW. I'm going to do something a little bit different in this video. I'm going to start out by giving a little mini story that I hope will help people understand what proof of work is a little bit more clearly, and then we'll go into the technical definition and some learning activities. Okay? Here we go. So the name of our story today is Blockman and the Puzzler. Are you ready? Let's get it. So, Blockman and the Puzzler. In the digital city of Blocktown, everyone trusts the blockchain. But how does the network decide which transactions are real and who gets to write them into history? That's where the miners come in. Every 10 minutes, a new challenge echoes across Blocktown. A cryptographic puzzle appears and every miner in the city races to solve it first. The network announces, whoever finds the solution earns the right to add the block and claims the block reward. Blockman powers up his mining rig. Time to hash, he mutters, watching his screen light up with calculations. Across town, his rival, the puzzler, grins at her monitor. Hope you've got enough computing power, Blockman. This difficulty target isn't getting any easier. Both miners start the same task, taking the pending transactions, adding a random number called a nonce, and running it all through a cryptographic hash function that secures Bitcoin. The output is a seemingly random string of numbers and letters. But they're not looking for just any hash. They need one that starts with enough zeros to meet the current difficulty target. The only way to find it? Guess and check, billions of times per second. Blockman's rig cycles through nonces. The puzzler's machines do the same, burning electricity and racing against the clock. Suddenly, Blockman's monitor flashes green. Got it! Blockman broadcasts his solution to the network. Every node in Blocktown verifies the math instantly. The hash is correct, the transactions are valid, and the work has been proven. The block is added to the chain. Blockman earns his reward, freshly minted Bitcoin and transaction fees. The puzzler's machine stopped mid-calculation. She shrugs and resets for the next round. You found the nuts first this time, but I've already started guessing for block 10,001. The race never stops. Every 10 minutes, a new puzzle. Every solution, proof of work. All right, good. Well, let's dig a little bit deeper, right? Let's find out exactly what proof of work really is. So that story helps us to maybe understand a little bit more about what's happening. But let's get to the technical side of things here. So as always, I like to start off the definition of our concept with a little quick quiz. And I made it a little bit easier this time. We've only got one block here. So what we need to do is take a look at this definition of proof of work. And we need to decide which part is missing behind the block. Maybe this is kind of a puzzle for us to solve. All right, so is it A, B, C, or D? Take a look there. Let me know what you think the answer is in the comments down below. Pause the video and then unpause it whenever you are ready. Okay, here we go. So the definition here says part of a proof of work is part of a consensus mechanism where participants compete to solve complex cryptographic puzzles in order to validate transactions that are in the block, right? So the winner earns a block reward, newly minted cryptocurrency, and transaction fees. Let's go over this a little bit. So proof of work is how decentralized networks like Bitcoin agree on which transactions and which blocks are valid. Since there's no central authority, miners, which are people who are running the powerful computers, or the powerful computers themselves, step in to maintain the network's honesty. Each miner tries to add a new block of transactions to the blockchain, but before they can, they must prove they've done the work. This is the computational effort that shows they're playing fair. That's the proof in proof of work. In return, the winner earns a block reward, which is usually newly minted cryptocurrency and transaction fees. This is how new Bitcoins are created and how miners are incentivized to keep the system secure. Okay. By this point, we have a decent idea about what proof of work is, right? This is how the system, uh, you know, verifies those new blocks there. But how does this really work? Let's take a look here. So how does proof of work, right? Let's zoom in on what happens behind the scenes. So each new block starts as a kind of digital challenge, as we saw in our story and a little bit in our definition before. Miners take all the block's data, including the block header, and run it through a hashing algorithm. For example, and many times this is the SHA-256, but we won't go too deep into that now. The goal is to find a special number called a nonce that makes the resulting hash begin with a certain number of zeros. The pattern of zeros represents what is called the difficulty target. It's like a guessing game, guessing a combination, like guessing a combination lock with billions of possibilities. Every guess takes computing power and electricity. The first miner to find the correct nonce announces their results to the network. Other miners quickly verify the solution, and once confirmed, the block is validated and added to the chain. Okay. All right. But yeah, we get that, right? But how do these nodes actually verify that the winning miner, the miner who solves the puzzle first, how do they verify that this nonce is correct? Let's take a look at that here. So, uh, first, a miner broadcasts their solution to the network, right? This includes the block data and the winning nonce that they have discovered. Other nodes on the network take that exact block data and nonce. They don't need to trust the miner, they can verify it themselves. Next, they run it through the hash function. That's it. They run it through the hash function one time, just one calculation to prove it, right? Then they check to make sure the resulting hash meets the difficulty target. If it does, the nonce is valid and the block is accepted by the network. But if it does not, the solution is rejected immediately. Okay, now here's the brilliant part about all this. Finding the nonce requires billions of guesses and a massive computational power. It's expensive and time consuming, but actually verifying the nonce just requires a single calculation. Once the miner finds the correct nonce, it's very quick to verify. So this part is actually cheap and fast. So this asymmetry, hard to solve but easy to verify, is what makes proof of work both secure and efficient for the network. The constant puzzle solving is what keeps blockchain decentralized and tamper resistant. No single entity can rewrite history without redoing all the computational work. And established networks like Bitcoin, that would be extremely infeasible and nearly impossible. The network's security grows with every block that is added to the chain. So every time as the chain gets longer, it becomes more and more secure. All right, this is one of my favorite parts here. It's time for the learning challenge. We got the gap field here. You know what to do. We have three choices here to fill in the gaps of our statement here. Take a moment on each one of these. You can pause the video if you want to. Try to find the answer, guess the answer, or maybe you already know it. You can write it down on a piece of paper. Let us know in the comments below, however you want to do it. Okay? Just pause it and unpause it whenever you are ready. Here we go. So in PoW, participants called miners compete to solve cryptographic puzzles for the right to validate a block of transactions and earn rewards. Okay, miners rush to find the correct nonce that produces a valid hash according to the difficulty target. Other nodes in the network verify a miner solution by taking the block data, then running it through a hash function. Okay, good job. I hope you got all those correct there. If you did not, no worries. We're learning. And one of the best ways to learn is by doing and failing a little bit. We fail, we get things wrong, then we say, aha, and we go back and we look at it again and we learn it, and it stays in our mind. That's why you will never forget how to ride a bicycle. Because to learn how to ride a bicycle, you're going to fall many times, and your brain is going to say, I don't want to fall anymore. Let's learn how to do this. Learning is much better than memorizing. Here we go. All right. Thank you very much. As always, I appreciate everyone who comes here and checks out these videos, trying to push forward their learning there. If you want to go a little bit deeper, you can check out the links in the description below. Got a few full lessons over there and some quizzes and a bit more information for you to check out. Once again, thank you very much for checking this video out. We'll see you on the next one.